Statistical significance is something that we're going to focus on in the class, and that is because what we're going to be doing is essentially running kind of like little experiments by being given data. And we're going to look at how good is this data? Was this data likely, could it have happened by chance, or did it happen because it's good data, because it would be very rare to happen normally? And there's a big difference between that and practical significance, because, and one of the examples that like I might give would be if you were to, for example, do a weight loss program, and over time it was found that people that did this program typically lost 5 pounds over the course of 2 months with this program. And this program costs like money. You might think, okay, well, statistically speaking, people lose weight on this program. Like, if they do some sort of data collection and they look at it, people lose weight, on average 5 pounds over the course of 2 months. However, I'm an intelligent, rational, thinking human being, and I realize that that's not a lot of weight. And so would I really want to pay that money for that program? And so we want to be thinking always about practically, is the data we're finding practical? Is it useful? We never want to just say, okay, we did this experiment, boom. We want to think about what that might mean in a practical sense. Okay, so for example, in a study of the gender aid method of gender selection used to increase the likelihood of a baby being born a girl, 2,000 users of the method gave birth to 980 boys and 1,020 girls. Would you pay $50,000 to use this method? So thinking about that, you might be like, well, I don't have $50,000, so how could I ever pay that? But most people don't. But let's say you want to have a girl. So you say, okay, well, they did this thing, and this is the fraction, also known as a proportion, of girls that came out from this method. And then when you do it and you look at it, you might say, well, that's 0.51, which is 51%. And you might think, well, I'm a rational thinking human being, and I should have a 50-50 shot of having a certain gender if I was to attempt to have a child. And so 51, not so much. Not so much of an increase. So when we think about this, this isn't much of an increase over, 50-50 chance of a girl. Personally, I would not pay $50,000 for this chance. So understand that their data says, hey, we do have an increase. We got an increase, but it's 1%. So that's the difference between statistical significance and practical significance, and we always want to be thinking about that. And the last thing in this section here of 1.2 is levels of measurement. And levels of measurement, of which there are 4. So it's basically how can we think about data in terms of how much measurement is possible for that data. So there's 4, and the first one is typically the easiest one. It's data that has no way to measure it, like literally no way to measure it. So if I asked all of you your favorite movie, and I collected the data from that, I have the names of all these movies, there is no way to measure those names. There's no way to say this name is higher than another name for some reason, or there's not amounts there. Your favorite movie is just names of the movies. So that's an example of a nominal. So the way I think about nominal is typically thinking about name, nominal name. As I used the example earlier, another example would be, say, shirt color, because I'm getting answers like red or blue or black, and there's no way to measure that data. Now, ordinal level of measurement would be the next one. And this is data that has some order, but we can't determine the differences. And what I mean is, like, we can't say this is this much higher or this much lower, but like we know that it is. We just can't quantify that. So an example of this would be, say, satisfaction after an oil change. So let's say you go to some place and get your oil changed, and then they're like, how happy are you with your service? And what a lot of places will do now, my CrossFit actually does this, when you leave, there's this little thing on the wall, and it's like, how was your workout today? And it's like it's like electronic, and you can press this one, or you can press this one, or you can press this one, and like, obviously they're hoping for which one? They want the person that smiles. And so we can categorize it. We know that the smiley face is better than the unhappy face. However, there's no way to say, oh, this is that much better than this one. We just know that there is a way to order it, but to actually quantify that order, we can't determine how much the difference between them. We just know one is better than the other. So that's ordinal level of measurement. So a little bit of order, not a lot. The interval level of measurement is, we have differences in the data. So we're increasing the level of measurement here as we do this. So for interval, we have differences and they are meaningful, meaning we can quantify them in some way. However, no natural zero starting point. And using the idea of a ratio is meaningless, and I'll mention that when we talk about ratio. One example of this would be IQ, and that's because there is no one that has a 0 IQ. So IQs are actually, like, this is some measure of intelligence. People do these intelligence tests, and the average on that is actually 100, and then it goes back and forth from, like, you could have a IQ like Sheldon from the Big Bang Theory with, I don't know, he had an IQ of like 160 or something. Somebody who might have some mental deficiencies might be more like an 80. And so we know just from these numbers that we can order those numbers. However, 0 is not a natural starting point. So 0 is not where intelligence begins, basically. So I'm also going to use the example of temperature. And the reason I like using this one is because students know, hey, it's hot outside. So say that it's 100 degrees outside, like that is really hot. And say yesterday was 80 degrees. And you could say there is a 20-degree difference in how hot it is. And you know that because that is quantifiable. However, if it was 0 degrees outside, that doesn't mean an absence of temperature. That doesn't mean there's no temperature. So that's what it means by no natural zero starting point. So temperature, Fahrenheit, the way that we do it in the United States, is an interval level of measurement, no natural zero starting point. Now the ratio level of measurement is like the most measurement you could have with data. So you've got a natural zero starting point. You can use words. If you can use words like double, triple, things like that, half, when talking about that data, then you know you have ratio. So notice it says 0 indicates none of the quantity is present. So if you have 0 of it, you got nothing. That's how you know you have ratio. And a good example of that, I mean, one of the most basic examples, I'm sorry for the beeping, is income earned in a week. So money is a very, very common thing. So let's say you earn $500 a week. But let's say your friend Joe earns 1,000. So he earns double what you make. And you also know that if you don't work, you don't make any money and you got 0. And that's that natural zero starting point. That if you have 0 amount of dollars, you have no dollars. And so that's an example of the highest level of measurement, which is ratio. It's the most, we can measure it the most, I guess, in the most obvious ways. So let's finish this section by looking at the level of measurement for these. So go ahead and see if you can do it, and then we'll come back and see if you got it right. All right, so nation of origin is going to be nominal because you're going to give the title of a country. So you're going to say the United States, or you're going to say Mexico or Canada, and those are words and those are names. Movie ratings, 1 star through 5 stars. So in a case like this, we have ordinal. We know that there are, that it's better to get 5 stars than to get 1 star, but there's no way to quantify the differences between them. We just know that like one is better than the other. Volume of water, that's going to be ratio, because, and notice a lot of continuous data is ratio. Think about, this person used twice as much water when they took a shower as me. They used like 5 gallons of water. I only use 2.5 gallons of water. So when you can use words like double, triple, again, then you have ratio. Year of birth of college students. So anytime you're talking about years, you're going to have interval, because I know that you, probably all of you, were born after me. But year 0 doesn't mean there was nothing. Like we don't have like nothing in year 0 and then the first person was born like at that first second or something. So we don't have that natural 0 starting point with years. Highest degree confirmed, we're back to ordinal, because we know that if you were to have a master's degree, like I do, that I have more education than somebody with a bachelor's degree. But again, to be able to quantify that is not possible. We just know that it's more education, but trying to quantify it is not something we can do. Eye color, we're back to the idea of nominal. We're getting answers like, oh, your eye color is blue, or your eye color is green or brown, and so we're not getting anything with numbers at all. Assessed value of a home. So now we're back to money. So say your home is worth $472,000, not kind of maybe even low for LA now. That is ratio. So it's very easy to say, oh my gosh, this person paid triple what I paid for my house, or this person's house is assessed at double what mine is. So those are always the idea of ratio when you can use those words. Time of day measured in military time. So this is interval. And the reason for that is military time uses a 0 to 24 hour clock. So it doesn't start back at 12. It goes to like 1300 hours if you've ever seen that in movies and stuff. So the reason that's interval is because we know that something's happening, 10 hours from now, and it's happening at, 1700. But when you start back at 0, that 0 is not a natural starting, there doesn't mean that nothing is there, no time is happening. Time is still happening at 0, hours. So that's why it's interval. All right, so practice these in the homework, and that is section 1.2.